Hello everyone, I am Dr. J. Krishnaraj, Assistant Professor from the Department of Automobile Engineering, Hindustan College of Engineering and Technology, Valley Campus, Coimbatore. In this video smart class, I am going to be brief about that, understanding the engine management system in our automobiles on the topic of this. So the overall outline of this presentation, we are going to be covered that introduction part of engine management systems, basics about the automobile engines, need of engine management system, components of engine management system, working of engine management systems, key features of modern engine management system, benefits, challenges and its case studies. The introduction about the part, the engine management system. As we know that automobile engines, that converts the chemical energy in the form of fuel into the heat energy, that is on combustion, again that heat energy into the mechanical energy in terms of RPM, revolution per minute. So in terms of power output. So on which even it is a petrol engine or diesel engine, so it is very important thing engine management system. So on which the engine management system that manage all the operations of the engines. So when it is going to be making fire, either it is in spark or fuel injection or opening of valve, closing of valve, admitted air quantity, quality, all those things. So it controls by the engine management system. And very earlier, so we have mechanical components and mechanical systems that controls the opening and closing of valves and spark produced and the like in fuel injections also. All those things which are controlled by the mechanical components, so that we get a lesser in power in huge cubic capacity of vehicle, as well as we cannot able to achieve the higher accuracy as well as performance, fuel economy, all those things. So at present now we introduce electrical and electronic systems in terms of ECU, sensors, actuators, for which so it is precisely monitoring the measurable quantity, so in terms of position, temperature, all those things, as well as the ECU so will convert the sensorical data into the machine language. So based on that, the actuators like in fuel injector or spark plug, all those things, so called to be as an actuators, so will act smartly. So even if you wanted to change the timing, so opening and closing timings, so we can easily modify all those things. So make an advancements of function, making a retardation of the functions, all those things possible in this scenario of advanced electrical and electronic system, especially engine management system. So the basics of the automobile engines. So yes, internal combustion engines are there, on which internal combustion engine it is classified into CI engine as well as SI engine, diesel engines as well as the petrol engines. Along with that, so it is having an hybrid vehicle technologies also be there, pure electric vehicles are there, and rotary engines are rarely used in this. So the basic engine components are like an cylinder, piston, crankshaft, valves, camshaft. So the engine is divided into three parts. So we can dismantle the engine into three parts. So the topmost part is cylinder head, middle part is cylinder, and the bottom is crankcase. So inside the three parts, so these components will be placed like a valve and valve trains, piston, connecting rod, crankshaft, camshafts or flywheels, everything, that is cylinders, everything are placed. So the working principle of engines is purely based on the cycle. So the conversion of fuel into mechanical energy, so either if it is a two-stroke engine or four-stroke engines, it has their own working principles called to be as an Otto cycle as well as the diesel cycle. So these cycles are derived from the Carnot cycle. So Nicholas Otto, who derives the principle of working principle of petrol engine, so that it is called to be as an Otto cycle. Rudolf Diesel, who invented the diesel engines and its principle called to be as an diesel cycle. So the need for engine management system. What is the need for the engine management system? Yes, so very earlier we have only mechanical components. So due to that mechanical components, we cannot able to achieve much fuel efficiency, safety aspects also. So like in pre-active safety, we don't have that. And like in performance, efficiency, all those things, it is lagging in this. So it is introduced that engine management system. So the traditional engine systems faces challenges in optimizing the performance and efficiency. So that the engine management system offers an advantages of such as real-time adjustments of and performance and optimization. So we can adjust real time. So if you are giving a sudden acceleration, based on that it is proactively active and it delivers the power that makes all the functions advanced. Sometimes it makes a retard functions also. So on real time, that can varies the functions. It is possible only by means of engine management system. So that having an evolved to address the limitations of traditional engine systems and improve overall functionality in all the aspects. So it improves the overall functionality. So the components of the engine management system. So what are the components? So that needs to adapt additionally to the mechanical type of engines. So even all the mechanical systems are exhibits in the same. Additionally, that are controlled by these systems. These systems are supportive systems, not in main. So these electronic systems will support to the existing mechanical components. So what are the components in the engine management system? The first one is ECU, engine control unit. Sometimes it is called to be as an ECM, VCM, like that. Different names are called, but the functionality are same. The ECU is the brain of our engine management system, especially for controlling the enginal functional. So separate ECU is given for that. That is the master brain for the entire working principles that controls the entire working of the engines, either making an advancements function or retard function, or convert the sensorical data into the machine language, as well as the actuating the actuators, as well as the controlled area network, CAN networks, everything that is managed by the ECU. It is just like an microprocessor. So this microprocessor is controlled several microcontrollers. For example, fuel injection unit that is having a separate microcontrollers that is controlled by this ECU microprocessor. Then second thing is sensors. Sensors play a crucial role in collecting the data about the engine performance. Various types of sensors are used in this purpose. So for collecting the various functionalities, the functionality called to be as in position, crankshaft position, camshaft position, throttle positions, air pressure, air temperature, coolant temperature, oil temperature, pressure, coolant pressure, fuel pressure, like that, different functionality measurements that is carried out by means of these sensors. These sensors inputs is given to the ECU. ECU having an coding, so it is having a language of coding with an embedded systems that converts the sensor inputs, that is run the codings, then it delivers as in terms of output of signals. These output signals will give it to the actuators. So what is actuators? Actuators are the responsible for making the adjustments based on ECU instruction, called to be as a signal. So called to be, what are the actuators are there, like fuel injector is some kind of actuator, throttle controllers are kind of actuators, like electronic valves are actuators, like several n number of actuators that are used in our automotive systems that can vary its functions based on the ECU signal. So the working of engine management systems. So these three are the important thing. So sensors for measurable quantity, ECUs for reading and give it of the signals. So that signals are given to the actuators. Based on this, actuators will function. So this working can be elaborated. The first thing is data collections and sensor inputs. Based on the sensors locations, so different sensors are placed like in position and temperature, position sensors are there, temperature sensors are there, pressure temperatures are there, and different kind of like load cells or like an oxygen sensors, lambda sensors. Okay, so different types of sensors are located in different positions. For example, if you are looking into this pressure sensor, for engine functionality, it needs coolant pressure, oil pressure, fuel pressure, like different of pressure sensors are used. In similar way for temperature sensors also. So thermocouples sometimes used, thermistor also be used for different kind of applications. Based on the different kind of sensors that collects all the data togetherly through controlled area network, it sends the signal to the ECU. So all the sensor data collected togetherly and it is sent to the ECU. So for every instantaneous time, it collects the data and send the ECU. So it is the main function of sensors. So the ECU and ECU processing. So the ECU will runs off, it gets the power from the battery for functionality only. Inside that it is having a programmable device that is run by means of like programs. So various kinds of programs, not on common programs like starting from the Java to Python and like an embedded codings, everything that are used based on the manufacturers, it will be differ. Based on the signal inputs from the sensors that is converted into as a machine code, zeros and ones. All the sensor data are converted into as machine codes that is introduced into this coding. Then it is run of this coding. Based on this, it gives the output. That output is converted into a signal. Based on this signal processing unit, it gives the signal to respective actuators. Because all the sensors, all the actuators are connected to the ECU. So how the respective actuators will recognize the signal now? So for which it needs CAN network and signal processing unit. These signal processing unit will gets the signal from ECU. Based on that, which respective actuators will actuate. So based on that, it gives the coding value. So in terms of signal, okay. So in terms of signal, it gives the signal output. So it is a controlled area network is in common. All the actuators is connected in the CAN network. So it that signal is reaches to the all the actuators, but only that particular actuator capable to run that code, that particular actuator only will actuate. For example, electronic valves also connected in the CAN network, fuel injector also connected in the same CAN network. But for example, 1011 is the output code, means that 10 is the respective code for the fuel injector. If it is 0 and 1, if it is 0111 means that 01 code will respect to the valves, electronic valves. Likewise, so that can capable to understand that. Then actuators will actuate based on the signal. Whenever it gets the signal, it will actuate. Either it is an advanced signal is reached, means it actuates advanced. If it is retard signal, means it will act as a retardance. Then real-time adjustments and optimization is also possible in this engine management system. So instantaneously, if you are suddenly giving an acceleration, that real-time adjustments are made. It makes an advancements in the function. If it is a down climbing means in the hills means, so that makes a retard function so that the vehicle can able to control in the downstreams. And then sometimes optimization. So everyone having a doubt about this. What is the optimized working in our engines? Yes, of course, for Bharat Stage 6 norms. So we need to optimize the engine performance also in terms of emission. If higher emissions are produced, means that so the O2 sensor will give the signal to the ECU. So it is a more unburned hydrocarbons are emitted, means that the EGR will open. That unburned exhaust gases again redirect into the cylinders. So again it makes a combustion and try to make it as a complete combustion. So that is one way of optimization. Another way, post processing are there, ammonia injection, other things are there. So we'll have a separate class for discussing all those things. So the next, the key features of modern engine management systems are like precise fuel injection systems. So accurately it can capable to inject the fuel, like in split injection, sequential injection. Split injection means, so for example 1 ml of fuel injecting to the single cylinder is split into 3 stage or 4 stage, like Tata Safari Dicar, they are introducing such a technology. And the precise fuel injection, so the precise quantity of fuel injection is made possible in this. Then advanced ignition systems. So either we can make an advanced ignition or retard ignition. So real-time scenario it can capable to adjust. Then efficient air fuel ratio control. So through gasoline direct injection GDI technology, turbocharged GDI technology. So it is based on the air that is exist in the intake manifold, based on the turbocharger power that can capable of efficient air fuel ratio control. So whether the driver is demanding high power or normal power or due to the airflow, it can maintain the stoichiometric rich or lean mixtures. The next is variable valve timing for optimum performance. So either if you are making an advancements of engine operations, so the VVT or VTVT, so that varies the valve timing, either advanced opening of valves or retard opening of valves. Based on that, the air fuel entry and combustion, everything that makes an advance or retard. Then integrated diagnostics and error handling. So on this integrated diagnostics and error handling, the OBD tools plays a vital part. So on which this OBD tool, this reads all the sensor actuators ECU signals based on this CAN network that is capable for identifying the health status of each and individuals. And of course, so while automobile vehicles are running, it is possible to make an error codes. So these error codes and like failure of components is capable for identify in this OBD tool. So it is an important and advanced feature in our engine management system, because in very earlier it is very difficult to identify the fault component. So we need to remove all the components, we need to check it up all the components. But at present now, through OBD tool, if you are connecting the OBD tool, if you are switched on the engine, within a second that read all the data, error codes, everything, error components, failure components, and health status of the components, it give it up, through which we can understand and we can remove and we can replace the parts. And the last one is adaptive engine control for real-time optimization. Based on this real-time operations and requirements, so the adaptive systems are used. For example, if you are looking to this ADAS, so on this ADAS, so it makes an automation of functions. So it can varies the air fuel ratios, like in power, torque, everything that is made possible in this adaptive engine control techniques. So through which, what are the benefits of engine management system? So the first one is improved fuel efficiency. So in very earlier we can look into this environment. So like nowadays at present now, the cars, petrol cars will capable of producing per liter, so it gives the power in terms of fuel efficiency 25 to 30 kilometer per liter. That much efficient we reached. It is possible only by means of this engine management system. So we are eliminating the fuel injection timing, everything, all the aspects. The next, enhanced performance. In very earlier, like in 3-liter engine capable of producing only 75 bhp of power. But at present now, 1-liter turbocharged GDI engine will deliver 130 PS of power. 130 PS of power. So the cubic capacity is reduced, but the power is increased. It is possible only by means of this engine management system. Introduced several things like a turbocharger introduced, like an electronic components, actuators, everything they are introduced. The next is reduced emissions. So of course, so like with the help of EGR, exhaust gas recirculation, with the help of lambda sensors and ammonia injections, so it is reduced the emissions also. So that made it possible to run the vehicle in BS6 at present now. So BS6 is a stringent norms for the emissions. So through which engine management system that made it possible to reduce the emissions, exhaust gas emission, and the diagnostic capability. Yes, of course, through OBD tool we can able to diagnostic the component error codes, failure part, and non-working components, and the health status of the particular component. That eliminates the measure of time. So what are the challenges and futures in the trend? So ongoing challenges in the engine management, such as balancing efficiency and performance. So that is an important and future trend for the challenges. And emerging technology in engine management like integrated AI for real-time optimization. So now at present the researchers are working in the introducing the integrated AI for real-time optimization that makes an autonomous of vehicle. So various stages of autonomous vehicles are there. So it is in the future trend. Future development and innovation such as more electrification and hybridization. So we people are nowadays moving to hybrid vehicles. So the hybrid vehicles capable of running the IC engine as well as in the battery also. Electrification also, they are plug-in hybrid, like various technologies they are introduced in this. So the case studies, some of the case studies for the achieving of better performance and efficiencies, the successful implementation examples of automobiles are engines that have benefits from advanced engine management systems. Performance improvements observed, measurable enhancement of fuel efficiency, power output, or other relevant metrics. So in the aspect of lower cubic capacity, we achieved a higher power output, and fuel efficiency also we achieved more in the fuel efficiency, and reduced vibrations, harshness, temperatures. So in all the aspects, engine managements that achieved a lot. So what is the lesson learned from that? Insight from the implementation of the process and usage of engine management systems. So there is ultimate key features. So you can able to get it from this video lecture. So what is the overall conclusion? So what the readers or listeners can get it from this? So the overall summary key points of this is recap the importance of engine management systems in the automobile. So the brief overview of key components and working principles of the engine management systems that highlights the benefits, future trends of the engine management system. So some of the important systems we discussed, the like modern automobile engine management system emphasizes how the engine management system have improved the fuel efficiency, performance, and emissions in our vehicle. So the overall conclusion back to presentation by retaining the importance of understanding the engine management system working, advancements, and like then remedial actions in this. Thank you everyone.